Okay, well, welcome back. So you can see that I've added even more to my little board here. I now have a total of 8 LEDs. I've got a total of 8 resistors. And I have those LEDs hooked up to pins 2, 3, 4, 5, 6, 7, 8, and 9, all nicely linked in. What I wanted to do is touch a little bit more upon this point about looking at the code here, the data direction register. Recall ever so briefly that I said if I wanted 8 LEDs from the last video, that I need to steal 2 of them from port B, okay? Because 2 of the ones from port D are set for transmit and receive serial signals, and they're kind of committed to that. So it's just as easy to go ahead and steal 2 from B. And that's exactly what we're going to do, but I wanted to elaborate a little bit more on this for those of you who aren't familiar with binary. The way it works is by counting in binary. You start with this lowest bit right here, which is a value of 1. That one has 2, that one has 4, that one has 8, that one has 16, 32, 64, 128. Okay? And each of these individual ones correspond to these pins right here. So if I look at, this would have been pin 0, D pin 0. No, actually it's not. This one is. This is D pin 0. This is D pin 1. Then this is D pin 2, which it is labeled as 2. Okay? That pin 2 corresponds to this 1 right here, which I've set to output. This pin 3 corresponds to this 1 right here, which I told to output. On and on. This pin here corresponds to this 1 here, where I've told it to make it an output. These 2 pins down here, 8 and 9, are actually on port B. So now I have another data direction register, port B, and I've told it that I want the 2 lowest bits, which corresponds to 0 and 1 of port B, or 9, 8 and 9 as labeled on this chip, to be output. So that explains that chunk of code right there. Okay. What you see going on in this code is I wanted it to count, because actually what I'm going to hopefully use is a set of LEDs as an indicator of analog values when we build a little robot platform using this breadboard. So we won't have LCD displays, and we won't have to have it tethered to our computer to see the analog data and whatnot come through the serial window. What I've done here, and I modified this piece of code. I've got a reference, and I'll post this on our site from this DY Robotics Labs WordPress.com site. What we've got is, as the numbers, as this variable, which I've labeled CT for counter, counts from 0 to 255, incrementing by 1 every time it goes through, so 0, 1, 2, 3, all the way up to 255. What it is we look at each individual bit, and if the bit is high to make that number, and okay, it compares against what we've said here, this binary value. So if there is a 1 in this position of a binary number, and well, we do have 1 here, if both of those match up, we're going to light the LED up. Okay? And second digit, okay, I'm sorry, not second digit, well, the 2 position of the binary value, if that is lit up or high, and this one is, which of course it is, I've set it that way, if both of these parameters match, then it's going to light up the second LED. And you see it counting up, okay, faster and faster and faster. It counts up higher and higher, and then it resets itself when it's 255. I can just as easily make this go, we'll make a countdown, in which case then I have to make that, we have to go this way, greater than 0, and we have to start it at 255, or some value. Alright, and let's see, that should actually make it count down. And it should all light up and then start sliding down. Okay, so we switched the direction of the counter without any problem. And if it's, you can change it once again. We can change the speed. You can make it really slow, and we'll just trudge through it. Okay, so hopefully that kind of clears up this and shows you. We'll probably put this into a subroutine at some point when we want to display values. But this is a way to make a simple binary counter, and we will move on from there. So I'll see you in the next video.